the previous video, we mentioned that Habitat 67 is characterized by its unique structure and design. Although it appears to be stacked concrete boxes, there is a clear order and design within. This reflects a bottom-up design strategy based on the relationships between individual units. Additionally, modular pixelation creates diverse spaces and enhances connectivity with the surrounding city or natural elements. These features transform Habitat 67 from a simple building into a city-like environment, creating a distinct and dynamic atmosphere overall. Today, we will introduce the overall construction process of Habitat 67 and how and where the pile foundation was applied to the site using actual drawings used in the construction. We will then showcase the process of moving the constructed modules to their designated positions and the cranes used to lift heavy modules to higher levels. Additionally, we will explain how the modules were stacked securely and stably, protruding outward without collapsing, and how the load of the modules was distributed. Habitat 67 can roughly be divided into 5 clusters. Its 3 largest face Avenue Pierre du Py, while 2 smaller clusters give onto the St. Lawrence River. Construction began on the southernmost large cluster and proceeded north. The boxes were assembled independently of the elevator shafts up to the level of the first walkway on the 5th floor. On that level, the boxes were connected to the walkways by post-tension cables for rigidity. Some of the boxes on the 3rd floor are supported by columns on the 2nd floor plaza level. Elevator shafts were built by assembling precast units one above the other. At the level of each walkway, which is 5th, 6th, 9th, and 10th floors, the elevator's concrete encasing was used to anchor the large walkway slabs down. Each house has at least one outdoor terrace, which is formed by the roof of the dwelling below. The modular boxes are assembled in a clustered geometry, with 8 boxes piled on top of one another. In the latter part of today's video, we will explain about a cluster. Habitat 67 is constructed on an artificial landmass created for Expo 67, which means the ground is weaker than other areas. Therefore, it was necessary to effectively drive piles to distribute the load of Habitat 67. A pile foundation aims to distribute the load over a wider area through piles rather than concentrating it on specific parts of the ground. When dividing the structure that distributes the load of Habitat 67, it can be broadly categorized into box clusters, horizontal street girders, vertical elevator towers, and columns. In the drawings, you can see that the piles are concentrated under the vertical elevator towers, columns, and the bottom box clusters, which bear the largest vertical loads among these structures. Furthermore, it can be observed that 3 piles are installed under each pile cap. We will delve into this aspect more thoroughly in a future video when we explore the load-bearing capacity of the horizontal street girders and columns resting on the pile caps. So far, we've explored the pile foundation of Habitat 67. Now, let's move on to how the modules used in the construction of Habitat 67 were transported and lifted using which cranes. A 100-ton rubber-tired straddle gantry then raised each box out of its formwork and transported it to the stockyard where it was sandblasted, after which crews post-tensioned and grouted the steel rods within the beams and walls. Moved to a finishing area, the unit received all components, fixtures, and finishes, including pre-assembled kitchens and a pre-modeled reinforced fiberglass bathroom. The gantry brought the precast box within reach of a stiff-legged mobile derrick crane. This gigantic structure, constructed by Dominion Bridge Company of Montreal, the storied builders of Canadian infrastructure since the 19th century, stood on 24-meter-high stilts set 21 meter by 21 meter apart, its boom reaching 61 meter. The crane hoisted the unit out of the plant yard, rolled over the site on a rail track which is mounted on the foundation beams or slab footings of Habitat itself. Thus, resist the massive erection loads and lowered each box into its designated place. The only way the derrick crane could actually set many of the concrete boxes in place was, in fact, with the aid of a 130-ton crawler crane, since the derrick crane only had a capacity to lift 70 tons to 120 feet. Some concrete units weighed up to 90 tons. In previous presentations, we've observed that Habitat 67's modules are not simply stacked in a straight line, but pop out here and there. This raises a question. How can the modules be stacked without collapsing during the stacking process? If we place a module at the bottom and then stack another module on top in this manner, the structure would likely be very unstable and collapse, unless a substructure capable of supporting the load of the modules is installed before placing the modules on top, or unless modules are not stacked directly on top of each other immediately after placement. This structure would collapse under the weight of the module placed on top. However, in the actual construction process of Habitat 67, neither substructures were installed before placing modules on top, nor were modules stacked directly on top of each other immediately after placement. The reason for this can be understood when viewed from above. In each floor, two modules were arranged in an L-shaped configuration, and on top of them, another two modules were arranged in a similar way. This allowed modules to be stacked one by one without the need for substructures or counterbalancing modules to prevent collapse from above. As evidence, numerous photos from the actual construction of Habitat 67 demonstrate modules positioned stably without the need for substructures or modules providing counterbalancing forces from above. However, even with modules arranged in an L-shaped configuration, you might still wonder if these modules would truly remain stable without collapse. The answer is yes. The modules used in the actual construction of Habitat 67 had grooves at the points where modules joined together, as you see now. These grooves allowed the modules to interlock, forming a more solid structure and maintaining stability. Whether these grooves serve simply to create a solid structure or to facilitate the connection of various wiring and utilities will be explained in more detail in the next video. In this way, Habitat 67 was completed by stacking 354 modules. Even though the external dimensions of the 354 boxes were identical, there were 136 different configurations of the basic module, the rest being either mirror or repeats of these. Among the modifications brought to the basic module was the wall thickness, which through generally 13 cm thick, increased to as much as 30 cm depending on the box's location within the structure. Therefore, close to 40% of the 354 precast modules of Habitat were unique. Most intriguing from a structure point of view were the clusters of prefabricated modules. Each cluster consisted of 8 boxes, 2 per level, arranged in a L-shaped pattern. These 4-story box clusters were tied together with post-tension cables, creating a single structural entity. This L-shaped pattern arranges in space, next level generated by rotating the lower module by 180 degrees. The same operation is used to generate the next level. Roof of the lower level becomes terrace space. Next level generated by mirroring the lower module and then rotating by 90 degrees. Different terraces are created due to the different operations. The clusters were also fastened to the horizontal street girders located at levels 5 and 9, which were themselves supported by the vertical towers and columns. The clusters as well as street girders were inclined about 60 degrees in respect to each other. The Habitat 67 was therefore based on the stacking of 3 clusters of boxes tied vertically to each other and horizontally to the street girders, all of which rested on a poured-in-place structure at plaza level. In this presentation, we explored various aspects of the construction process of Habitat 67. We began by discussing the construction sequence and site selection, followed by examining the design and construction methods to maintain the stability of the structure. We looked into the crane operations related to module installation, considerations for the foundation, and the structural connections between modules. Finally, we summarize the overall structure of Habitat 67 and its method of load distribution. In the next video, we will delve into whether the groups on the modules were solely for structural stability, or also serve to accommodate wiring and utilities. Additionally, we will explore how the clusters we discussed today transfer loads to the horizontal street girders and how these girders, in turn, distribute the load to the vertical elevator towers and columns. We will also explain why Habitat 67 resembles a pyramid with modules arranged wider at the base and narrowing as they ascend. Thank you very much for listening to our Team 7 presentation.